prepare for the Minnesota Journeyman Electrician test, review the Minnesota Electrical Code. Since this is an open book test, become familiar with the National Electrical Code, focusing on articles covering common electrical tasks and safety regulations. Master calculations. Calculations are heavily tested, including Ohm's law, power, and circuit analysis. Practice these calculations thoroughly using reference materials and online resources. Analyze sample questions. Study practice tests or sample questions to identify areas where you need more practice. These questions can be found online or in exam preparation materials. The test format includes 100 multiple-choice questions, a 5-hour time limit, and allows the open book National Electrical Code. To take the test effectively, manage time effectively. Don't spend too much time on any one question. If unsure, flag it and move on. Read questions carefully. Questions may be worded trickily or have multiple parts. Read them carefully and understand what is being asked. Use the National Electrical Code wisely. Use the National Electrical Code to look up specific code articles or to clarify concepts, but don't rely solely on the National Electrical Code for answers. Review answers. Before submitting, take time to review the answers and correct any errors. The test will likely cover electrical theory, the electrical code, electrical calculations, wiring methods, electrical motors, transformers, grounding and bonding, and safety practices. Get restful sleep. A well-rested mind will perform better on the test. Calm nerves. Practice relaxation techniques such as deep breathing or meditation. Consider a study group. Studying with others can provide different perspectives and support. If struggling with specific concepts, consider hiring a tutor or taking a preparation course. Remember, preparation and a positive attitude are key to success. By following these tips and studying diligently, you can increase your chances of passing and becoming a certified electrician. The test includes questions on electrical theory. Electrical theory forms the foundation of understanding how electrical circuits and systems operate. Key concepts include voltage, current, resistance, power, and the relationships between them as defined by Ohm's law. You should be familiar with series and parallel circuits, as well as the effects of inductance and capacitance. Understanding alternating current and direct current principles is crucial. This includes knowing how to calculate root mean square values, peak values, and power factors in alternating current circuits. You should also study the behavior of resistors, inductors, and capacitors in alternating current circuits. The test includes questions on the electrical code. The Minnesota Electrical Code is based on the National Electrical Code, a comprehensive set of standards for safe electrical installations. Key articles and chapters to focus on include Chapter 1, which covers general requirements, definitions, and rules for electrical installations. Chapter 2 focuses on wiring and protection, including overcurrent protection, grounding, and bonding. Chapter 3 deals with wiring methods and materials, detailing the types of cables, conduits, and other wiring systems allowed in various applications. Chapter 4 covers equipment for general use, such as receptacles, switches, and lighting fixtures. Chapter 5 addresses special occupancies such as hazardous locations, healthcare facilities, and places of assembly. Chapter 6 covers special equipment, including electric signs, elevators, and electric welders. Chapter 7 addresses special conditions such as emergency systems and fire alarm systems. Chapter 8 covers communication systems, including telephone, radio, and television installations. Familiarize yourself with tables in the National Electrical Code, such as those for conductor ampacity, conduit fill, and box fill. The test includes questions on electrical calculations. Electrical calculations are a critical part of the electrician's job, ensuring that electrical systems are safe and efficient. You should be proficient in using Ohm's law to calculate voltage, current, and resistance in circuits. Power calculations are also essential, including single-phase and three-phase power calculations. Understand how to calculate voltage drop in conductors to ensure that equipment receives adequate voltage. Be able to calculate the size of conductors and overcurrent protection devices based on the load requirements and the National Electrical Code tables. You should also know how to calculate fault current to ensure the proper selection of overcurrent protection devices and equipment. Motor circuit calculations are frequently tested, including determining the full load current, branch circuit conductor size, and overcurrent protection for motors. The test includes questions on wiring methods. Wiring methods refer to the various ways electrical conductors can be installed and protected. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. You should be familiar with the requirements for each wiring method, including where they are permitted to be used and how they must be supported and secured. Cable types include non-metallic sheath cable, armored cable, and metal-clad cable. Each cable type has specific applications and installation requirements. You should also understand the requirements for installing conductors in raceways, including conduit fill limits and earthing factors. The test includes questions on electrical motors. Electrical motors are used in a wide range of applications, and electricians need to understand how to install, maintain, and troubleshoot them. Key topics include motor types, such as induction motors, synchronous motors, and direct current motors. You should understand the principles of motor operation, including how motors convert electrical energy into mechanical energy. Motor control circuits are also important, including starters, overload protection, and control devices. You should know how to calculate the full load current, branch circuit conductor size, and overcurrent protection for motors. Familiarize yourself with the National Electrical Code requirements for motor installations, including grounding and disconnecting means. The test includes questions on transformers. Transformers are used to step up or step down voltage levels in electrical systems. Key topics include transformer types, such as step-up transformers, step-down transformers, and auto-transformers. You should understand the principles of transformer operation, including how transformers use electromagnetic induction to transfer energy between circuits. Transformer connections, such as delta and Y configurations, are also important. You should know how to calculate transformer voltage ratios, current ratios, and power ratings. Familiarize yourself with the National Electrical Code requirements for transformer installations, including overcurrent protection and grounding. The test includes questions on grounding and bonding. Grounding and bonding are critical for electrical safety, preventing electric shock and minimizing the risk of fire. Grounding refers to connecting electrical equipment and systems to the earth, providing a low impedance path for fault current. Bonding refers to connecting non-current carrying metal parts of electrical equipment and systems together to create an electrically conductive path. You should understand the purpose of grounding electrode systems, including ground rods, ground rings, and metal water pipes. Familiarize yourself with the National Electrical Code requirements for grounding and bonding, including conductor sizing and installation methods. You should also know the difference between equipment grounding and system grounding. The test includes questions on safety practices. Electrical safety is paramount for electricians, protecting them from electric shock, burns, and other hazards. Key safety practices include always de-energizing circuits before working on them, using lockout/tagout procedures to prevent accidental re-energization, and wearing appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. You should be familiar with the hazards of electricity, including shock, arc flash, and arc blast. Understand the importance of maintaining a safe working distance from energized equipment. Familiarize yourself with the National Electrical Code requirements for safety-related work practices, including the use of ground fault circuit interrupters in wet locations. Remember to study these topics thoroughly and practice applying your knowledge to various scenarios. This comprehensive preparation will significantly increase your chances of passing the Minnesota Journeyman Electrician test. Always prioritize safety and adhere to the electrical code. Firstly, review the NEC thoroughly. Secondly, master electrical calculations. Thirdly, analyze sample questions. Fourthly, manage time effectively during the test. Fifthly, read questions carefully. Sixthly, use the NEC wisely during the test. Seventhly, review your answers before submitting the test. Eighthly, get restful sleep before the test. Ninthly, calm your nerves before and during the test. Tenthly, consider studying with a group of fellow electricians. Lastly, seek professional help if needed. Always ensure all equipment is properly grounded. Always check for correct voltage and amperage. Always use the right tools for the job. Always follow the lockout/tagout procedures. Always maintain a clean and organized work area. Always inspect your tools before use. Always be aware of your surroundings. Always communicate effectively with your team. Always ask questions if you're unsure. Always double check your work. 1. Understand Ohm's law. 2. Understand power calculations. 3. Understand voltage drop calculations. 4. Understand conductor sizing. 5. Understand overcurrent protection. 6. Understand motor circuit calculations. 7. Understand transformer calculations. 8. Understand grounding and bonding requirements. 9. Understand wiring methods. 10. Understand electrical safety practices. The Minnesota Journeyman Electrician test evaluates a candidate's knowledge and skills related to electrical installations, safety, and code compliance. The test generally includes questions on the National Electrical Code, electrical theory, calculations, wiring methods, motors, transformers, grounding and bonding, and safety practices. It's designed to ensure that electricians are competent and qualified to perform electrical work safely and effectively. Preparing for the Minnesota Journeyman Electrician test requires a strategic approach to cover all relevant topics and familiarize yourself with the test format. Dedicate ample time to studying the National Electrical Code, electrical theory, and calculations. Utilize practice tests and sample questions to assess your knowledge and identify areas for improvement. Seek out experienced electricians or instructors for guidance and support. Prioritize sleep, nutrition, and stress management in the days leading up to the test. With thorough preparation and a positive mindset, you can increase your chances of success and achieve your goal of becoming a licensed journeyman electrician.